Today, I want to show you guys how to use calculus to find an approximation for 1 over 3.6. And in fact, this is my exam question that I gave to my Calculus 1 students during this summer. And of course, I had to write down some directions so I can ask them to actually use some calculus instead of just do like 1 over 4, because 4 is pretty close to 3.6. And if you do 1 over 4, well, you have 0.25. That's an approximation, but that's not calculus. So here is the direction. What we want to do first is we are going to find the linearization. And this just means that we want to find the equation of the tangent line to a curve at some x value. So we want the linearization of the function 1 over x, because we have 1 over something. And I asked them to do it at x equals 3. As you may see textbooks, they say linearization of a function at a equals 3 is fine, because x is equal to a, so our 3 right here is the a. And once we have that, I'll just say then use it to approximate 1 over 3.6. So you really have to do calculus right here. Okay, the calculus part is, first, what does linearization mean? In fact, we have a pretty nice formula, which is this one right here. L of x is equal to, let me write it down first and I'll explain. We have f of a plus f prime of a times x minus a. This is a very nice formula, but why though? Why does this work? Well, in fact, you know this formula really well already, but this is just a calculus form for it. Have a look. From your algebra class, we have learned how to find equations of a line. We have the point slope form, and that is y minus y1 equals m times x minus x1. Well, let's bring this to the other side. Now, we are going to rewrite this in the calculus form, which is going to be the one that you see right here. Let me start from right and we go back to left. Firstly, our x1 value is the given x value, and we are going to label that as a. And then the subtraction stays the same and the x stays the same. Parentheses, of course, stay the same as well. What's m? The slope. But right here, we want to what? The slope of the tangent line, right, for linearization. So that is the derivative, f prime of a. And then we add, what's y1? When we know x1 is at a, we can just plug it into our function. That will give us the y value corresponding to this x value. So that will just be f of a. And then our y is precisely our linearization. So this is how we have that. Now let's just go ahead and get to work. First, I'll just write everything down right here for you guys. Our function is 1 over x, and a is equal to 3. So we want f of 3, and that is just 1 over 3. Done. Next, we want the derivative. The derivative of 1 over x is negative 1 over x squared. You can write this as x to the negative 1 power. Bring the negative to the front. We have the negative 1 here. And then subtract 1 from the exponent. So we get x to the negative 2, which you can bring that down right here. Well, you can just remember it from here to here, because this is a pretty common function. If you know it, then you can write it down, so you don't have to do the power rule every single time. Then we want f prime of 3. That means we just have negative 1 over 3 squared, which is negative 1 over 9. Now let's use this formula. Our linearization is f of a, which is 1/3. And then we add f prime of a, which is negative 1 over 9, times x minus a, which is 3. And now we can distribute the negative 1 over 9 and then combine the numbers. So we will have 1 over 3. That is negative 1 over 9 times x. And then negative times negative, we have positive. 3 over 9 is the same as 1/3. And let's just rewrite this as negative 1 over 9x plus 2/3. Okay, so this right here is our linearization for the first part. But what does this really do though? Well, here's the idea. Our function is 1 over x, which is just a curve. But what we are saying is, this function is pretty close to our linearization here when x is around this value, which is 3. Let me write that down. We are saying 1 over x is pretty close to this thing here, which is negative 1 over 9 times x plus 2 over 3. When x is around 3. Based on all this, we are saying 1 over 3.6 is going to be approximately equal to negative 1 over 9 times, again, you put 3.6 into these x values. So this is 3.6. And then you add 2/3 to it. Now check this out. This is equal to what? 3.6 divided by 9 is 0.4 negative. Told you, works out pretty well, right? And then 2/3, you should know that as 0.6667. Add them up. Of course, you can just subtract 4 from here. So this right here is equal to 0.2667. So 1 over 3.6 is approximately equal to 0.2667 based on this right here. Of course, we can also just use a calculator or long division to do 1 over 3.6, and that's the answer. But where's the fun?